Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is a procedural programming module, and I'm going to continue with the session with the chapter, that is chapter number 21, that is more Linux programming. In the last class we have started with this chapter, that is how to do the Linux programming, that is a more Linux programming. That is, we have started with chapter number 21 in the last class, and we have covered topics. There are a few topics in this chapter, like these are the topics like communication using the signals, handling multiple signals, registering a common handler, blocking signals, event driven programming, where do you go from here, summary, exercise. So these are the various topics that is included in this chapter, and we have finished only one topic, that is the communication using the signals. We have studied about the theoretical, that is how what communication takes place, that is it is the essence of all the progress. That is, communication is very important in every field, whether it may be a real life, whether it may be a programming. Then we have studied that how to communicate using the signals. So this in the last chapter we have talked about the two signals, two library functions, that is the fork and the executable library function, that is the fork and the exec library function, to create a child process and to execute a new program respectively. These are the two functions that is used, these are the two library functions that is used to create a child process and to execute a new program respectively. These library functions got the job done by communication with Linux operating system. Therefore, the direction of communication was from the program to the OS. The reverse communication, that is from OS to the program, is also achieved using a concept that is known as signal. So signal is a concept that is used to get the communication from the operating system to the program. That is, operating system instruct the program that what has to done or what is to be achieved. That is achieved, or that term is known as signal. Let us now write a simple program that would help you experience the signal mechanism, that is, or that helps you to that how to follow the signal mechanisms. This is the program that is used. First of all, there is a int main, then there is a while1, then printf program running. That means it will execute n number of times, that is why it is while1, then printf program running, then there is a return 0. The program is fairly straightforward. So this is a straightforward program. All that we have done here is what we have used an indefinite while loop to print the message program running on the screen. When the program is running, we can terminate it by pressing the key, that is Control C. So this Control C is used for termination of the program. So termination is done by pressing the key, that is Control C. So when we press the Control C, the keyboard device driver informs the Linux kernel about the pressing of this special combination key, that is a Control C command. So this Control C is used for the program termination. But how on earth would the default signal handler get called? Well, it is simple. There are various signals that can be sent to a program. A unique number is associated with each signal. So a unique number is given with each signal. To avoid remembering these numbers, they have been defined in a macro. We have studied these macros also. These are defined in a file, that is signal.h, and these are the three macros that is used. One is the sigint, one is the sigkill, one is the sigcontinue, etc. in the file, that is the signal.h. Every process contains several signal ID, that is a function pointer, that is used for the signal for which the function have been called. If we do not decide to handle a signal, then against that signal ID, the address of the default signal handler function is present. It is precisely this default signal handler for sigint that got called when we press the Control C. Let us now write a program, that is how we can prevent the termination of the program after hitting the key, that is a Control C. This is shown in the program. So this is a program that we have studied, that is used for pressing the key, that is the Control C. So this is the hash include signal.h. Then there is a void sig handler int signum. This is the printf, that is a sigint received inside sig handler. So this is the printf statement that is used for the printing purpose. Then there is a int main, that is the starting of the main. Then there is a signal, then sig int, void pointer, sig handler. So this is the what we have studied, that is the signal function that is used. Then there is a while one, this is the indefinite loop. Then there is a printf program running. Then there is a return 0. In this program we have registered a signal handler for the sig int. We have studied this theory, that is how the signal handler is used, how to typecast the address, how to use the address before passing to the signal function, before passing to the next function. So this function would display the message, that is a sig int function that is used for the communication in the achievement of the target, that is a control C. Then we have studied that whenever we use the PSA command, that is used to process, or that is used to obtain the list of all the processes that is running in the, or that is running at the command prompt. So it shows each and every process that is used for the command prompt. Note down the process ID of a.out. That is, whenever we use the process PSA, that is used for listing each and every element, and the output file is created, that is known as the a.out. We have studied in the last class about the program, that is how to use the process ID, that is done by the k.out, and how to kill the process by using the kill command. Now this is the handling the multiple signal, that is how to handle more than one signal. So let's continue with the today's session, that is how to handle the multiple signals. So these are the three header files that is used. One is hash include unistd.h, this is hash include systypes.h, this is hash include signal.h. These are the three header files that is used. One is unistd, one is systypes, one is signal.h. This is the function that is used for the int handler. There is one variable, that is a sig num. This is the terminal, that is the term handler, that is the sig term. Then this is the continued handler, that is the sig count received. This is the main function. There is a signal, then sig int handler, the sig term handler, sig count handler. This is the while function that is used. There is a printf, that is a program running. In this program, apart from sig int, we have additionally registered two new signals. What is the new signal? That is the sig term and the sig continue. As in the previous program, here too we have pressed Ctrl C handler, that is called, that is the int handler, that is used, or that is called. However, when we try to kill the program from the second terminal using the kill command, the program does not terminate. So we have used the term handler that get called whenever we use the sig term. As a result, the printf statement in the term handler function get executed, and the message sig term received get displayed on the screen. This is the command that is used for the following program, that is for the another terminal, that is kill sig kill 3276. As the command indicates, we are trying to send a signal, that is the sig kill signal to our program. A sig kill terminates the program, that is used for killing the program. This is the sig kill. So there are three functions that is used. One is the sig kill, one is the sig term, one is the sig int, and one is the sig continue. These are the four signals that is used over here. This is the important one, that is the sig kill, that is used for termination of the program. So this says the sig kill signal is to be used as a last resort to terminate a program that gets out of control. One such process that makes use of this signal is a system shutdown process. It first of all sends the sig term signal to all the processes, wait for a while, and therefore giving a grace period to all the running processes. That is, sig kill is used and the sig term is used for the all the running processes. However, after the grace period is over, it forcibly terminates all the remaining processes using the sig kill signal. So sig kill signal is used. First of all, it sends the data to the sig term and then wait for a while, then give a grace period, And after the grace period is over, is forcefully kill the signal by using the command, by using the signal, that is a sig kill signal. That leaves only one question: when does the process receive the sig cont signal? That is how it will achieve the sig continue signal. A process under line X can be suspended using the control Z command. That is it will be suspended using the command, that is a control Z. This process is stopped but is not terminated. That is, it is suspended. That it is stopped but not terminated. That means it is suspended for a while. This gives rise to an uncatchable sig stop signal. To resume the execution of the suspended process, we can make use of the foreground command. So one command is used for the simple execution of the suspended process, that is the use of the FG command, as a result of which the suspended program resumes its execution and receives the sig continue signal. That means continue the execution. Now the next topic is how to register a common handler. This is the next topic, that is how we are able to register a common handler that is common for all the events, for all the transactions, for all the execution that is taken place by the signal. So this says instead of registering a separate handler for each signal, we may decide to handle all signals using a common signal handler. So we may decide to handle each and every signal that is using a common signal handler. This is shown in the following program. So that is shown in the program how to handle or how to use a common signal handler. So that is this is a program, that is #include unistd.h, #include systypes.h, #include signal.h. So these are the three header files that is used. Then there is a void sig handler and sig num. This is the sig handler, that is a signal handler is used. Then there is a int sig num, that is a signal num. Then there is a switch case, that is a switch sig num. Then case sig int. So this is a switch case, and what is the case first one? That is a signal int, that is a signal interrupt. Then simply use that the sig int received. Simply printf the statement, that is a sig int received. Then there is a break statement. Then another case is sig term, that is a signal termination. Then printf sig term received. Then sig continue, next case is, and the message is sig cont receive, that is a break. And this is the closing curly braces over here, and this is a closing for the void main. Then int main, that is the main function. This is a signal. These are the two arguments that is used. One is the sig int and one is the sig handler. This is a signal. One is the sig term and one is the sig handler. Then sig continue and one is the sig handler. These are the argument that is used. Then there is a while one, that means continuation of the loop for the n times. Then printf program running, that is it will print for the n number of times that is a program running. Then there is a return 0, and then int main is closed. So these are the various functions that is used. Whenever cursor moves to this one, that is a sig int handler, the cursor directly moves to this one, that is a sig int handler. Then sig term, then sig continue, sig handler. In this program, during each call to the signal function, we have specified the address of a common signal handler named the sig handler. So we have used a common signal handler for handling a signal that is known as the sig handler. So that is used for the common signal, that is the common signal that is used. Therefore, the same signal handler function would get called when out of 3 signals are received. This does not lead to a problem, since the signal handler we can figure out inside the signal ID using the first parameter of the function. So this is the signal handler that is function is used, that is a common, or that is a main function, or that is a common function that is used when the signal is received. In our program, we have made use of the switch case construct to print a different messages for each of the 3 signals. So we have used different messages for the different signals. Note that we can easily afford to mix the 2 methods of registering signal in a program. That is, we can register separate signal handler for some of the signals and a common handler for some other signal. So we have used separate signal handler for some of the signal and a common handler for the some other signals. Registering a common handler makes sense if we want to react to the different signals in exactly the same way. Then the next one is blocking the signal, that is how to block the signals. Sometimes we may want that flow of execution of a critical time portion of a program should not be hampered by the occurrence of one or more signal. In such a case, we may decide to block the signals. So this is a topic, this is the next topic, that is how to block the signals. So this is the case whenever there is an execution of a critical signals, time critical portion of the program that cannot be hampered by the occurrence of one or more signal. That will be hampered, or there are multiple signals that is collected together. In such a case, we may decide to block the signal. This is a scenario that is used to decide to block the signal. Once we are through with the time critical code, we can unblock the signal. That is, once we are moving forward from the critical time consuming code, we can unblock the signals. Note that if a signal arrives when it is blocked, it is simply queued into a signal queue. When the signals are unblocked, that is, whenever signals are unblocked, the process immediately receives all the pending signals one after the another. So whenever there is a requirement, or whenever the signals are unblocked, the process immediately receives, or the process immediately get all the pending signals one after the another. That is, one by one it will get the unblocked signals. Therefore, blocking of signals refers the delivery of signal to a process. That means, simple, block the signals whenever it is hampered by the occurrence of one or more signals. Instead of completely ignoring the signals or letting the signals interrupt the execution, it is preferable to block the signal for the movement. That is, if there is any error, so it is preferable, or it is a prefer to block the signal for the movement and then deliver for the later for the some time. That is, it is deliver them some later time. Let us now write a program to understand signal blocking. So this is a program that is used for the signal blocking. This is the program. These are the four header files that is used. One is the uni.std.h, then sys-types.h, then signal.h, then stdio.h. So these are the four header files that is used. Then there is a void signal handler in signum. That is, a signal handler is used. Then there is a int signum, that is a signal num. This is the void signal handler. Then there is a switch case, that is a signum. That is, a switch case is used, that is a signum. Then there are different cases of the switch case, that is a sigterm, that is a signal termination, that is a case. Then there is a printf, that is a sigterm received. Then there is a break, then case sigint, that is a interrupt. Then there is a printf, that is a interrupt received. So these are the various cases. Then sig continue, this is the signal continue, this is the same. Now there is a int main function, then char buffer 80. That means it is an array of 80 numbers that is used, or that is denoted by the null character. Then sig set t block, this is the function that is used. Then there is a signal, and these are the two arguments in this. What are the arguments? That is the sig term and the sig handler. In the same way, signal, sig int, and the sig handler. Signal, sig continue, sig handler. So these are the three functions that is called, or that is calling the function. That means these are the function that is used for calling the function. The function name is signal. Then sig empty set, that is sig empty set is used. This is also a function that also contains the address, that is the ampersand block, that is the address of the block. Then sig add set, block, address of block, and the sig term. Then sig x add set, then the address of block and the sig int. So these are again the two functions that is used. Then there is a sig proc mask, sig block, ampersand block, then there is a null. Then check the condition. This is the most important point. Compare the string. What are the strings? That is the buffer and the n. So compare the string n and the buffer, and if it is not equals to 0, that is, if it is not equals to 0, then simply printf enter a string. then gets buffer, then puts buffer. That means if first of all enter a string, then gets the buffer and then puts the buffer. Then sig proc mask that is used, then sig unblock ampersand block and there is a null. Then while one printf program running, that is program is running, that is a while one, that is the first condition. Then there is a return 0. In this program we have registered a common handler for the sig int, sig term and the sig continue signal. So these are the three macro that is used for the common handler. These are the common handler that is used. Next we want to repeatedly accept the string in a buffer and display them on the screen till the time the user does not enter an N from the keyboard. Additionally, we want that this activity of receiving input should not be interrupted by the sig int or the sig term signals. So we also consider, or we also see that whenever we receive the input, that should not be interrupted by the sig int or the sig term signal, that is not interrupted by these one. However, a sig continue should be permitted. So before we proceed with the loop, we must block the sig int and the sig term signal. That is, blocking is received by using the function that is a sig proc mask library function. The first parameter of the sig proc function specifies whether we want to block or unblock a set of signals, that is, whether we want that a signal will be blocked or not. The next parameter is the address of a structure, that is a type def as a sig set t that describes a set of signals that we want to block or unblock. The last signal can be either null or the address of the sig set t. So this is the sig proc mask. One is a sig block, then address of the block, then there is a null. There are library functions that help to populate the sig set t structure. What are the library functions? Or there are again the library function that is used along with the set t structure. One more function is used, that is a sig empty set, that is a signal empty set. If there is a signal empty set that is used, that have a sig set t as a variable, so that it does not refers to any, or it does not refers to any signals, that is a sig t function. So to block the sig int and the sig term, we have to add the signals to the empty set of signals. This can be achieved using the sig add set library function. The first parameter of the sig add set is the address of the sig set t variable, and the second parameter is the id of the signal that we wish to add the existing set of signals. After the looping, we have also used an indefinite while loop to print the message, that is a program running message. That is, after we have used the looping, after the looping we have used the indefinite while loop, that is while one, to print the program running message. This is done so that we can easily check that till the time the loop that receives input is not over the program, that cannot be terminated using the control plus C or the kill command. That is, this is the command that is used, that is either control C or the kill command, since the signals are blocked. Once the user enters a N from the keyboard, the execution comes out of the while loop and unblocks the signal. As a result, pending signals, if any, are immediately delivered to the program. So if we press Ctrl C or use the kill command, that is any case when the execution of the loop that receives the input is not over the signal pending. Once we are thorough with the loop, the signal handler will be called. Next is your event-driven programming. This is the next one that will be starting after the, or in the next class. Now first of all, let's take a break for 5 minutes, then moves to the next topic, that is the practical part of this one. That is the practical part. So in the next class, that is in the tomorrow's class or in the Monday's class, not tomorrow's, in the Monday's class, I am going to start with this topic, that is event-driven programming. And again I am saying this is a recorded lecture. If there is any doubt, then please refer the doubt or please mail the doubts to me so that I will answer you immediately, or I will answer you with the mail, or I will answer you on the Monday whenever I come to the class. That is on Monday, that is on 2nd of Feb. Right. So first of all, let's take 5 minutes break. Now let's start the session. Just come back from the break. Now let's move to the practical approach. That is the practical approach of the C language. In the last class, we have studied about the call by reference and the call by value. That is, what is the difference between call by value and call by reference. So let's continue with the function only. That is how to use the function. What are the different functions that is used over here. So these are the two header files that is used. And then there is a void main. Then there is a curly braces. So this is the program of the function that is used. How to use the function as an argument, or how to pass the argument as a function, or how to define a function in this. That is the next part. That is how to use the functions in the global variables. हेलो हेलो हाँ जी, मैं 2 मिनट में करता हूँ, 5 मिनट में करता हूँ, अभी क्लास ले रहा हूँ, बाद में करता हूँ. That is how to define a function, how to use a function, or how to pass a user defined function as an argument to the another function. That is how to pass the argument or how to pass the parameters to a function that is defined in the another function. Right. So there is a void main first of all. Then there are variable declaration, that is int, that is y equals to 2. Then there is a x. So these are the two variables that is declared. Then x equals to double. Then there is a bracket, then square. It's a function that has a parameter that is y. So this is the one is a double, then square, then y, then there is a semicolon. Then there is a printf. That is a printf, that is x equals to percentage d. Then there is a variable that is a x. Right. Then there is a closing curly braces over here. That is a closing of the void main. But first of all, we have to write the get ch over here. Then there is a closing curly braces. Then there is a definition of the function, that is the double. Then m. Then this is the closing curly braces. Then there is a return, that is return m into 2. That is a closing curly brace. Then double. Then again this is the square, that is a square function. Then there is a bracket. Then there is a k. This is the definition of this one. Then there is a closing curly brace. Then there is a return, that is returning the value, that is k into k. Then again there is a closing curly braces. Now if I compile this code, there are two errors. Declaration function square should have a prototype, that is it must be defined or it must have a prototype, that is either giving a prototype as an int, as a double. Right. So first of all, I will save this file. That is a function, that is a double, or that is simply a function, user defined function, that is uf. This is okay. Right. Now if I compile this code, there are two errors again. that is expression syntax, that is this is missing, that is expression syntax, that is square is used and the y is used and the square is closed. There is a double, there is a square function, right? If I close this one and simply give this one, now if I see there are again two errors, expression syntax, that is using this one, there is expression syntax over here, then y is assigned a value that is never used, that is y is giving a value that is never used because it is a square function, so y is giving the value. Now if I again compile, there are one core declaration syntax error, there is a declaration syntax error that is used, there is a return, there is a what is the output. In the same way, if I include, that is hash include math.h, if I say, now let's see, if I compile this code, again there are two errors, that is this line has some errors. If I again this square, that is a square function, that is square, S-Q-U-R-A-E, then if I compile, again there are two errors. If I give the int main over here, again there is a two error. So I will check this program and tell you what is the error, how this error will be removed, right? So let's start the new program. I will tell you the code in the Mondays class, the doubt in the Mondays class, that is how to use the code. So let's start another function, that is using the functions as an argument for the another function, that is how to use the argument as a other function, that is how to use the argument in a different function, right? So first of all, there is the stdio.h, that is the hash include, then hash include conio.h, then there is one more header file that is generally used, that is hash include math.h. So these are the three header files that is used. Then there is a void main, that is a void main function, right? Then there is a curly braces. Now we have declared one variable, that is d x, in bracket it is int comma int, then y, then z. These are the variable that is used. Then uses the d equals to, that is define the variables in another variable, that is the x, and the arguments of x is y and z. For example, z, then comma y, right? Then uses the printf for printing purpose, that is the printf, that is in double quotes it is /n, then there is a z minus y equals to percentage d, then uses the variable that is a d because the d contains the output, then there is a return 0, there is a return 0 over here, then this will be closed, or there is a not return 0, we have to use the get ch over here. Now we have closed the main function, then we have to declare the functions, define the function, that is int a and the int b, that is two variables are declared, one is the int a, one is the int b, right? These are the two variables that is declared over here, that is the int a and the int b. Then there is a return type, that is a return, there is a return, that is a return is used, return statement is used, Then this will be used for finding the absolute function, that is a minus b. This is the absolute value of this one. And then this is the closing of this x function, right? Then there is a y function, that is declaration of y. And then there is a int y, then CLR, SCR. So this is very complicated program, but we have to type it because we need to learn something, that is enter the first name. So this is the program that is used for entering the name. Then there is a scanf also, then percentage D, that is ampersand y, then there is a return y, then there is a closing of this y function. Then this is the z function, then there is a int z, then there is a printf, there is a slash n, that is enter second number, then there is a scanf, that is percentage D, then there is a return z, then again this one is closed, that is this one, that is this one, right? Now if I compile this code, there is one error, declaration terminated incorrectly, that is declaration is done incorrectly, that is this is not available. Now if I compile this code, again there is one error, that is statement missing, that is a statement missing over here. Here some place there is a statement missing, like this one, this is reversed. Now if I compile this code, there is a success. If I execute this code, enter the first name or first number, this is not name, this is a number. Enter the second number, that is 13, then x z y minus y1 equals to 1, that is the second number minus first number equals to 1. This is not a number name, this is a number. Again if I compile this code, enter the first number, for example 90, and so the second number, that is your 67, that is a z minus 1, that is the first number minus second number is equal to 60, without including, not first number minus second, that is the second number minus first number, that is the 67, without including the including the negative sign. Why? Because we have already used the function, that is a absolute function. This absolute function is used for finding the absolute values in the without including any spaces, without including any sign, that is either plus or minus sign. That is a 67. Right. Now if I compile this code, again if I give the value as a 28 and if I give the value as a 30, the output is 2, that is 30 minus 28 is 2. Now if so this is a program. First of all I save this program. So if I give the name as a long function, well this is very long, so we have to use the function, that is a long fun, right? Now we now try run the program. So first of all, 3 header files are introduced, that is the stdi.h, conio.h and the math.h. So these are the 3 header files that is used. One is the standard input output, then common input output, then math.h. Then there is a void main. That means the main function is used, that is a void main function. Then there is a int dx, that is d is the variable that is used. Then there is a x, that is a function that contains 2 variable, both of are of int type, that is a int. Then there is a y, then there is a z. So y function is used, then z function is used. Then uses the function, that is d equals to x z function, y function. So these are the two functions that is used. One is the z function, one is the y function. These are the argument of these functions. Then there is a printf, that is a printf statement is used. Then there is a printf as it is used. So whenever we have the cursor moves to this one, it directly moves to this part, that is the x part. That is the output of this function is stored in the d. This is int a, int b. Then there is a return absolute a minus b, that is a minus b is used. That is return the values of the z minus x, that is return the value of the a minus b. That is the a contains z and the y contains b. That is a minus b is your z, that is your gives the absolute value by using the function. This is the abs. So it simply gives the absolute value without including any sign, that is a plus sign and the negative sign. Then there is a y function, that is a y. Then there is a int y, then clear screen, then clear printf, enter the first number, that is enter the first number. Then there is a scanf, that is %d, then %y. This %y is used for getting the number, for storing the number into the memory, that is the %y. Then there is a return y, that is means returning the value, that is a return y. Right. So these are the first of all, this is the y function, this is the y function. That means the first number is the y function, that is the y, then return y. In the same way, second function, z function, is the second one, that is printf, enter the second number, then scanf %z. Then there is a return z. Then after using y and z, y gives the value as a y, z gives the value as a z. So now z becomes a and the y becomes b. So a minus b returns the value that is provided by the x function, and the output of x is stored in the d, and the d will be printed over here. In the same way, it will print z function minus y function equals to %d. That is, first of all, uses the function, defines the function, calculate the subtraction among these functions, and then displays the output as a in a variable, or stores the output in a variable and display the output using this function or using this variable, that is a d variable. Right. So this is first of all, it is a different one, and with this line we have to get the output, but using this line there are two functions defined, that is z and the y. So first of all, it uses the y function, then z function, and then there is a x function. So these three functions are used in one line only. That is, they are compatible with each other, combined with each other. That is x, y, z. First of all x, then define either x, z or y, any function. Then prints the value of d, because d contains the output of the function. That is the name of the function is x. So this gives the output. Now if I use the commenting over here, now if I compile this code, there is one error. Function absolute should have a prototype. That is, absolute function is not running separately. It has to be defined, or it is defined in the library function. So for whenever we use the absolute, so we have to define the math.h, or we have to include the math.h in the header files, because the absolute function is a library function that is available or that is stored in the math.h. Now if I remove this one, and now if I compile again, enter the first number, that is 22, enter the second number, that is 33, the output is your 11. Now let's start with another program. So I think this program is clear to you, that is how to use one function inside another function. If there is any doubt, then please mail the doubts to me, and I will answer you in the next class. Now let's use this another function that is used for the addition, multiplication. That means the how to use the operators with the functions. Right. So first of all is an assignment operator, that is how to assign the value by using the equals to. Then there is a addition, there is a subtraction, there are various operators, that is a user defined variables. Now, next is how to call the user-defined function through if statement. That is how to use the user-defined functions, or how to call the user-defined function with the help of the if statement. Write a program now. The header files will be included, that is hash include stdi.h, then hash include conio.h, then there is a void main, and then there is a curly braces, and then there is a function declaration, that is a function, right? Then there is a clr scr function. Now check the condition over here, that is using the if statement we have to check the condition. If a modulus 2, that is if a function modulus 2 equals to 0, if this is the case, then simply printf the number is even. Else printf the number is odd. Then close this one after using getch. Then uses the function, that is the a function. Then declare the function as a, then uses the printf, then enter the uses, that is enter value of a, then uses the scanf for this purpose, that is storing in the memory, that is percentage d, that is ampersand a, then there is a return a. Then this also will closed. Now if I compile this code, there is zero error. Wow, great. If I execute this code, enter the value of a, that is 10, the number is even, right? Now again, if I compile this code, if I give the value as a 3, the number is odd. So this is the simple finding the whether a number is odd or even, but within the function we have to use the if statement, that is along with the function it is using the if statement, or it is including the if statement, how if statement will execute. So first of all, there are two header files, that is stdi.h and the conio.h. These are the two header files that is included. Then there is a void main for including the main function, or for including in the main function. Then there is a int a, that means the a function is used, that is using the function, that is the a. And then there is a clear screen, that is clr scr. Then check the condition, that is a is a function that is defined of integer type. Then check the condition, if the a function, that is whatever the output of a function, that is modulus 2, or whenever we divide the function by 2, if it gives the output, it gives the remainder as a 0, then simply printf the number is even, else otherwise printf the number is odd. That is either printf the number is even, else printf the number is odd. Then there is a getch function for printing the output. Then again, this is the definition of the function, that is the a function. Then there is a int a, that is the this is the definition. Then it is using the int a, that is a is a variable that is declared, that uses the printf, that is used for the printf statement. Then it is printed that enter the value of a, that is enter the value of a, then scanf, storing the value of a, then return the value of a. So whatever the value that is returned by a function, that is used for the checking the condition, if it is equals to 0, then the number is even, otherwise the number is odd. Right. So these are the header files. This is the function. This is the function that is used, that is divided by 2. This is the function, and this function is defined, or this function returns the value as a. Then there is a modulus 2, that is equals to 0. Then printf, the number is even and the number is odd. Then there is a getch function. This is the a function. Then int a, printf, scanf, return a. Right. Now I have to save this file first of all. That is the even function, right? This is the even function. Now if I again compile this code, enter the value of b. For example, if I give 23, this is the odd number. If I give 20, this is the even number. This is the function that is used. If it is divided by 2, it is equals to 0, then it is the even number. Number. If it is the note gives the value as a 0, that means it is a odd number. So there are two terms, that is the even and odd. This is the example, that is how to write a program that is a user defined, or how to write a user defined function with the if statement. That is the if statement is used within the user defined function. In the same way, we can apply any rule, any processing, if statement, switch case, looping, for loop, while loop, any looping we can do, any statement, switch statement we can use, while loop, do while loop, iteration, and number of things that we can use. And we can also use the functions with the array, with the pointers, with the array elements, with the array to a function, that is n number of elements, right? We can also use the while loop in this, that is if it is not equals to 0, then printf this one, printf this one. So instead of this one, we can also use the while. Instead of if we can also use the while statement over here. So that means we can do n number of iterations within the functions, n number of looping within the functions. Now we have to close this one. So that's all for today's session. If there is any doubt, then please text the doubt and I will answer you. In the tomorrow's class, I'll be starting your next topic, that is the event-driven programming. That is in the Monday's class. I'm coming on the Monday. I will present on the Monday. So I'm taking your class. This is that is not a, or that will be not a recorded lecture. That is a video lecture. That is an online lecture. That is a live lecture. That is a real-time lectures. So again I'm repeating, this is the recorded lectures till now, or till today's class, that is from 22nd of Jan to 30th of Jan, that is the today's class. It is the recorded lectures except 26th of January, because 26th of January there is a Indian holiday in the 26th of January on account of Republic Day, that is Indian holiday. Else every recorded lecture is supplement to you, that is from Thursday, Friday, Tuesday, Wednesday, Thursday, Friday. So there are total 6 lectures that is recorded and that will be used to you. Now if there is any doubt, any kind of doubt, that may be little doubt, that may be major doubt, that may be silly mistake, any doubt you can ask from me. First of all, you can mail to you yourself, or either you can mail to me, so that you cannot forget the doubts. And definitely I will answer you the doubts in the Monday's class, that is the date after 2 days from today, that is the 2nd of Feb, and I will definitely answer you each and every doubt individually. So that's all for today's session. Thank you so much everyone. We will meet on Monday. Okay. Thanks a lot. Bye bye.